All right, for lesson 2 in unit 3, we're going to be performing basic operations with polynomials. We'll be adding, subtracting, multiplying these polynomials. We won't do division yet. This is basically going to be a rehash of what you did in, I believe it was lesson 2 of chapter 9 of Algebra 1. And again, it's been a hot minute since you've done that, but we're going to perform these basic operations by combining like terms when we add or subtract, or by doing our distributive property and then combining like terms when we multiply. So we have to understand how to add or subtract before we can multiply, just like you learn these operations in sequence in elementary school with numbers, with counting numbers and digits, and then we graduate to multiplication. We're going to do the same thing today. So the way that we combine like terms is we have to first identify what like terms are. And so like terms are those monomials that have the same variable and the same degree. So here, these have the same variable and degree, they just have different coefficients. So these are like terms. Over here, these have the same coefficients, irrelevant, the same variable, that's good, but different degrees, these are not like terms. Next, we have m cubed, but m squared. So same variables, but different exponents. These are not like terms. Whoops. Here we have, spoiler alert, we have different variables. Even though they have the same exponent, they have different variables. This is x and y, and so those are not like terms. These are just constants, all right? And so we can add those or subtract those. Those are like terms. And then here, these have the same a to the first power, the same b to the second power, just different coefficients. These are like terms. We could add those or subtract those. So making sure that you can identify like terms so that you can combine them using addition or subtraction is key. So we're going to do a little bit of this. So let's go ahead and try to combine like terms. The parentheses just group this expression plus that expression. You are welcome to shed those parentheses and pretend that they are not there, because we know that by the associative property, it doesn't matter how these expressions are grouped. It just matters that we are able to combine the like terms. So here I've got a cubic, I've got our quadratics, I've got our linear, and I've got our constant term. And these are already in order, which is pretty fantastic. So I can write this as 2x cubed minus 3x squared plus 7x plus 6. This is the simplified form after we have added and combined the like terms, the x squared, the 1x squared, and the negative 4x squareds together make negative 3x squareds. Over here, again, we have, these are maybe not in the right order, but I can write these without the parentheses so that I can then change the order. We're just adding. So we're adding this, and we're adding this, and we're adding this. And then I can shuffle the order around as needed. This is not a step that everybody has to do, but is one that I would recommend. I'm gonna write my cubics, negative 4x cubed and a negative 11x cubed. I've got a quadratic and a quadratic, so I've got a negative 7x squared and a positive 12x squared. And then I have these constants, 13 and 3. You don't have to use different colored pens, but sometimes it's helpful to change the order using the commutative property so that you can have like terms grouped together. This is going to give us negative 15x cubed. This is going to give us positive 5x squared. And this is going to give us 16. All right, so this is our simplified form. This was our simplified form. So these should look familiar based on Algebra 1 that you've done. But this one that I want you to try is maybe a degree difficult for you, because this is not maybe something that you explored too much in Algebra 1, but I want for you to try it. Let's see what happens. Can we combine our like terms? Can we identify our like terms and combine them? And things that are not alike, can we leave them separate? So you're just going to try this one. You know that I'm going to answer this for you. So give it a shot. Let's see what you end up with when you try that. When it comes to subtracting, we do have to be careful because there's going to possibly be some sign errors or some sign issues. And this is kind of a repeated theme that sometimes we don't subtract well. That's why we learn addition first and then we worry about subtraction. But if I'm going to shed my parentheses, I need to make sure that I'm subtracting 2x cubed and I'm subtracting negative 5x and I'm subtracting positive 4. So I had to give this negative sign to everything. Back in Algebra 1, they would say we're going to add -1 times, and then we change the signs for all of those things. That's essentially what we did. I'm not going to change the order on things. I'm just going to combine them in the right order. So I've got x to the 5th, no x to the 4th, so I've got some x cubes. I've got no x squareds. I've got x's that I need to combine. And then I've got constants that I need to combine. 1 minus 4 is -3. Again, when I'm subtracting, we want to make sure that we pay attention to the correct signs here. And so we're subtracting a -12x, that means we're adding 12x. We're subtracting a positive 9x squared, that means we're subtracting 9x squared. And we're subtracting a negative 11x cubed, so we're going to write that as plus. Combining like terms, we've got cubics here, so 8x cubed. Quadratics there, -8x squared. Linear terms here, 11x's. And no others. All right, so we have combined our like terms. On this one, again, I would like for you to try, and if you had trouble on the last one, you may still have trouble here. So what I want for you to do is after you write this down, I want you to also write down what happens when you distribute this negative sign, and then see if you can try to put these with their buddies that are going to be like terms, and see if you can combine those like terms. If you are confused on whether something is like terms, then leave them separate and then we will address it in class, but I will go over this one in class. Multiplying. Okay, so we've done adding, we've done subtracting, now we get to do multiplication. And for multiplication, I want to remind you that we're going to have to use distribution. We've already done this. We've distributed these, we've done double distribution here and here with FOIL, right? We've done squaring and then distributing the 2 and then adding the 3 when we went from vertex form to standard form last unit. And so this is going to seem like stuff that you've done before, and that's okay. If it's stuff that you didn't do well with before, now's the time to make sure that we do it well. If you did it well before, though, we want to make sure that we are accurate with our practice. So we're going to distribute this in here to get 3x to the 3rd power, x squared times x is x to the 3rd, minus 6x squared. Over here, I'm going to write out this factor twice. And then I'll come back to it, all right? I'm gonna come back to that one. This one, I want to do my double distribution. The way that I've written this out in the past when we did this last unit is I wrote it like so. A lot of you don't like to write that step, you just like to go right into double distribution or FOIL like your Algebra 1 teacher called it. And that's totally fine with me. I have no qualms about that. You do what you need to do to make sure that you can combine your like terms correctly and that you're doing a good job. But if you need to change the way you're doing something because you hadn't done a good job in Algebra 1 or the last unit, then I want to make sure that you do it well this unit. Over here, I'm going to multiply these first. I'm going to take 2 times 4x times 4x minus 3, minus 3 times 4x minus 3, and then I'll add 3. So again, 2 times 16x squared, minus 12x and minus 12x and plus 9, and then we're going to add 3. So now I get 32x squared minus 24x's, this is 24x's, and then I have to double it, so minus 48x's. And then plus 18, and then plus 3. So my final answer here is 32x squared minus 48x plus 21. This one, again, 3x squared, we're multiplying that by x minus 2, and we're multiplying 4 times x minus 2. So when it stops being something that you can just kind of multiply quickly in your head, that's why I love modeling the work that we know how to do without skipping that step, so that when it gets to harder questions, we can do that multiplication correctly. Now this is awesome because once I've done that double distribution, I don't have any like terms to combine like I did here to make my negative 24x's, and like I did here to get my positive 4x's. All right, so again, I wanted you to see those examples so you can kind of see some of those basics, but I've got more. We've got somewhere where I'm multiplying the same thing 3 times. I'm multiplying a binomial by a trinomial by a binomial. How can we make that work? So we are going to do our best to model that we're doing double distribution here, or that we are doing triple distribution on this one, so that you can break it down into smaller chunks that you can multiply. The number one hesitation I see with students and the number one issue I see with students on these types of questions is skipping this basic step. If you skip this step, you might wreck the work that you could have done quite well otherwise. When we multiply two y's and 5x's, I'm getting 10 xy's. And then here I have 25 x's. Over here, this is negative 12 xy's and a positive 8y squared and a negative 20y. Let's go ahead and see what like terms we've got. I've got x squareds over here. I've got xy's that I can combine. So I've got negative 22 xy's. I've got 8y squareds. And then I've got 25 x's and negative 20 y's. So it's maybe written in kind of a funny order. Here's the deal though, degree 2, degree 2, degree 2. These are all degree 2's, these are all degree 1's. And so the order on these doesn't really matter, all right? But usually when we have x's and y's together, we'll put the x squareds, the xy's, and the y squareds together, all right? Kind of in that order. And then when we have x's and y's, we usually put x's before y's. I know it seems a little bit silly, but if you have these in a different order, I don't think that I'm counting that wrong, right? So I'm just happy that you multiplied correctly, right? And combined your like terms, that's awesome. Over here, when we do our distribution, we get 24x cubed minus 32x squareds. I get 18x squareds and a negative 24x's. I get a positive 12x's and a negative 16. And you can see that we've got like terms and like terms. So let's combine those like terms. This is minus 14x squareds. This is minus 12x's and minus 16. All right, I'm probably gonna have you do this one. But over here, I don't want this video to take forever. I want you to be able to move on with your life. When we are multiplying multiple things, we're gonna take them in stride and do one part at a time. So I'm gonna multiply these first, and then once I get that trinomial, I'm gonna multiply it by this binomial. So it's gonna end up looking like this one. But first I need to do this multiplication. So I'm gonna have 3x times x minus 3 and 2 times x minus 3. And I'm gonna take that multiplied by 2x plus 1. So when I do this multiplication, I get 3x squared minus 9x's and 2x's minus 6. And then I'm going to take that by 2x plus 1. So this gives me 3x squared minus 7x's, minus 6, multiplied by 2x plus 1. I'm going to write here that you finish. It's going to look like this one where you have a trinomial by a binomial. You're going to do that work that we just did there. For x plus 5 to the third power, I want for us to recognize that this is x plus 5 and x plus 5 and x plus 5. So we can't just make x cubed plus 125. That's not going to work, right? We know that there's going to be some squared quadratic terms. There's going to be some linear terms along with those constants. All right, and so I would like for you to try to finish H. You try to finish G. And the goal on that, again, isn't to make it super challenging. You're going to try it. You know that I'm going to go over those in class. I'll change my color coding on here so that when I pull it up in class, I'll remember that we need to check over G and H. My hope is that by the end of that practice, and after seeing those examples, that you feel comfortable and confident with combining like terms to add or subtract polynomials, and you feel comfortable with distributing and then combining like terms in order to multiply polynomials. All right, see me with questions or post a comment on Google Classroom.